For the other strain gauges 1 and 2, there's a different state of stress. The shear is going to be constant, and it's present at 1 and 2, but not present in the rest of the strain gauges. And that shear is going to be P over 2, positive P over 2. There's also going to be a moment, and that moment is going to be different. It's going to be P over 2 times some length. That length doesn't really matter because we're located at the neutral axis, so the moment shouldn't be affecting the stresses at all. We do, however, have these angled. So our state of stress is going to be a classically pure shear state. We're going to have no normal stress in the x direction, and we're going to have no normal stress in the y direction or z direction, because we're at the neutral axis. Now, when we're using a strain rosette, because these two are lined up at angles, we are going to want to use this equation, which some of you are probably wincing at. But strain the x direction times square of the cosine, some angle theta, strain the y direction, sine squared of the angle theta, plus the shear strain times the sine of the angle theta times the cosine of the angle theta. However, even though this looks horrible, let's remember that we know this has to be 0 because this is the case. And we know that this has to be 0. So, all we've got are this. And because we know the angles, the angle that this one is at 45 degrees. This is number 1 right there. That's 45 degrees, which means that this will just become the shear strain times 1/2, because that's 45 degrees. And both of these, the sine of 45 degrees and the cosine of 45 degrees, are 1 over the square root of 2. Similarly, for the second strain, all of this will be identical. This will still be 0. This will still be 0. But we will have negative 45 degrees for this second strain gauge, which means that the cosine will remain positive, but the sine will become negative, which means that this is going to be negative 1/2 the shear strain. So if we want to know the shear strain, what we'll do is we'll take the strain output for the first strain gauge, and we'll subtract the strain from the second gauge.